Okay, in today's class, we talked about gas stoichiometry, and just a quick review. What we're really going to be doing here is using stoichiometry and gas laws to predict amounts from a balanced equation or from gas law variables. So we could be solving for grams of a substance in a balanced equation, for moles of a substance, or we could be solving for pressure, volume, or temperature using moles as a piece of information, possibly. Essentially, what we're going to do is we're going to use Pivnert once, and we're going to use stoichiometry once. Now, over here, what we're going to be trying to hone in on is where is the gas in this problem. When we're looking at these balanced equations, I would maybe start out by circling the gases, just to remind ourselves that gas stoich is going to involve pressures, volumes, and temperatures of gases. So we need to find and identify that gas in the balanced chemical equation. Now, if you are given pressure, volume, and temperature, we're going to use Pivnert first to find moles. Then we're going to use gas stoich to solve something else. Now, if you're asked for pressure, volume, or temperature, that means we're going to use stoich first to find moles of gas, which is N, and then we can do Pivnert second once we have the moles. Let's do some practice problems down here. So first, when propane is burned, C3H8, burned means reacting with oxygen. It produces carbon dioxide and water. It's just a combustion reaction. We've practiced this the previous unit. So it looks like I have 3 carbons here, so I need a 3 here. I have 8 hydrogens here, so I need a 4 here. 4 times 2 is 8. And now it looks like I have 3 times 2 is 6 oxygens, plus 4 more is 10, so I'm going to want a 5 here. So it looks like this is a 1 to 5 to 3 to 4 ratio. Now, last unit we did practice that these CO2 and H2O are both gases here, and this oxygen would be a gas. And I would expect you to maybe know what propane is, but maybe we can think about it based on the gas grill at home. We'll be okay not knowing that for now, though. So first question here, if 100 grams of propane is burned, how many moles of carbon dioxide could be produced? This is just a stoichiometry problem. So we're going to set up our 100 grams of C3H8 on the left. Let's write down what we know. We're going to moles of oxygen, CO2, carbon dioxide. This is a grams to moles problem. Let's think for a second. How many steps was this again? Okay, that's 2. First step is canceling out the grams of C3H8. 44.11 grams of propane are in 1 mole of propane. Grams cancels. Now, how do we go from moles of propane to moles of CO2 is we look at the balanced equation ratios. And for every 1 mole of propane, we produce 3 moles of carbon dioxide. So we're going to take 100, divide it by 44.11, multiply it by 3, and we get 6.8. And I guess if we have 4 sig figs there, 6.801 moles of CO2 is the best answer. Now, how can we use this? Now, what is the pressure caused by the carbon dioxide in a 2.5 liter container at 22 degrees Celsius? So we need to use this moles of CO2 as our N, moles of gas. So we're going to be doing Pivnert here. It's asking for pressure, so I'm going to say pressure times. My volume is 2.5 liters. N was 6.801 moles. It doesn't mention in this problem, so I'm just going to use my first R value, 0.0821 liters per ATM over moles Kelvin. And my temperature would be 22 plus 273. We must use Kelvin in gas law formulas. So it looks like I have pressure times 2.5 equals 6.801 times 0.0821 times 295. So we solve for P and we get 66 atmospheres. And atmospheres is our unit because we use this R value. So we performed stoich first, and then we did Pivnert. Okay, let's do another problem from beginning to end. 5 grams of sodium is added to excess water, so plus H2O. So this is a tricky one, but we need to think of H2O as HOH plus minus. So the sodium would go with the OH plus 1 minus 1 to produce sodium hydroxide. And I guess the hydrogen would then be kicked out of the party here. And we remember Hunkelbrief, it would actually be H2. Now, at this point of the year, I kind of expect you to know that H2 is our gas. Now, it's asking for what is the pressure. Now, remember, when a problem is asking for pressure, volume, or temperature, we're going to do stoich first to find that moles of gas. Then we're going to use Pivnert second. So let's take our 5 grams of sodium and start with that. So we have 5 grams of sodium. We need to find moles of gas. Now the gas again is our H2. And I said earlier it would be helpful to kind of identify that in the problem. So let's find moles of H2 from grams of sodium. It looks like that's a two-step problem again. Sodium is 22.99 grams per mole. Whoop, I think we need balanced equation ratios. We never balance this. Let's go ahead and do that. Na, H2, H2. Oh, there's 3 of them. We need to get an even number here. So now we have 4 H's on this side, 4 H's on this side, 2 sodiums. Okay, now it's balanced. Now we can use balanced equation ratios. So it looks like for every 2 moles of sodium, we're going to produce 1 mole of hydrogen gas. So here we have 5 grams divided by 22.99 divided by 2, and we end up with 0.109 moles of H2 gas. Okay, now that we have moles, which is N, we can use Pivnert to solve for that pressure. So pressure times volume, it says this is happening inside a 1 liter flask or 1 liter rigid container. Here is our moles. Let's go ahead and plug that in down here, 0.109 moles. It didn't specify the units. I'm just going to use 0.0821 again. If you used a different R value, you would just end up with a different unit of pressure as your answer. And then my temperature would be 12 plus 273, 285 Kelvin. Okay, solve for pressure, and the pressure is going to equal 2.6 atm. Okay, I hope this helps. I'm going to post another video going over the second practice series.